Okay, the first topic is just some basic concepts in geometry. Probably you have already heard some of them. In that case, you can treat this as a review lesson. Okay. Okay. First, the concept of points. This is a very basic element in geometry. Well, there's nothing special about a point. Be careful, usually we'll use a uppercase letter, for example P, to denote the point, and since we can't move on the point in any direction, we say a point has 0 dimensions. And in order to tell one point from the other, we usually label them with capital letters, such as P here, okay? And next, the concept of segments or line segments. If there were a straight path from one point to another, that path will be called a line segment, or just in short, a segment. The 2 points at the end of the segment are called endpoints of the segment. Usually we'll use these endpoints to label the segment. For example, if you just want to label the segment itself, we use a short bar above the 2 endpoints here, AB, with a bar on top of it. But if you only want to label the length of this segment, usually you can omit a bar, okay? So AB denote the segment itself, and if you want to write AB, for example, equals 1.5 inches, then in this case you can omit the bar on top of it. Be careful with the difference here. Can you follow me? Very straightforward concept, right? Okay, then let's see another concept, which is called midpoint. A midpoint is just a point halfway between the endpoints of a line segment. Because midpoint is the same distance from both ends, we say it's equidistant from the endpoints. For example, in this diagram, the point M is the midpoint of segment X and Y, because XM equals YM. And usually we'll use this notation to denote the lengths which are equal. So you can put a little mark here to denote XM equals YM. Or if you want to denote XZ equals WY, you can put 2 little strokes to denote these 2 lengths are equal. Alright, these are some commonly used notation to denote equal lengths. Any questions? Okay, and next we're going to have a look at the rays. If we start at a point, then head in one direction forever, we form a ray. Just like its name, it looks like a ray, right? Or a starting point is the vertex of the ray, and we denote the ray as AB. For example, A is the vertex of the ray, and we can find any arbitrary point beyond the ray, then denote the ray as this symbol here, A, B, followed by a small arrow on top of it. So this is a ray. It has an endpoint, only has one endpoint, and it can extend indefinitely to the direction here, right? Where the first point is a vertex of the ray. The vertex is also called origin of the ray, and the ray often leave off the little arrow here. Okay, by the way, if you have any questions or feel any confusion, just interrupt me, okay? I need to make sure you can follow my lead, okay? Otherwise, I'll just go to the other slide. All right, next lines. If we continue a line segment past its endpoints, both of its endpoints, forever in both directions, then we can form a line, which we write as AB with a new direction arrow on top of it. So this indicates a line. Okay? So this is a line segment, right? This is a line and this is a ray. Be careful with the difference, okay? Two endpoints, one endpoint. There is no endpoint for the line because the line can extend indefinitely to both ends, okay? And sometimes we also use a lowercase letter to denote a line. For example, we could also use a line K here. So we could use line K. Any questions? All right, then next concept. There are two trivial concepts which are collinear and concurrent lines. If three or more points are all on the same line, we say these points are collinear. For example, on the left diagram, we can say points A, B, and C are collinear. And if three or more lines all pass through the same point, as shown here on the right, then we say the lines are concurrent. Okay, there are two trivial concepts. So when we talk about collinear, then you should know collinear means all the points are on the same line. And on the other hand, if a question tells you some lines are concurrent, that means all the lines pass through the same point. Right? Okay, don't worry. You don't have to write down everything, okay? After each class, I'll give my notes to you, okay? Of course, you should have your own journal, but only write down the concept that you think is important, okay? And next, concept of planes, two-dimensional, three-dimensional, or 2D and 3D. On a surface like this page, for example, if you consider it a page or a screen, we might call all dimensions left, right, and up, down. If the page extended forever in every direction, we'd call it a plane. And a two-dimensional or 2D object is an object that only has two dimensions, such as a length and a width, and no thickness or height. A three-dimensional or 3D object is an object with three dimensions, usually a length, a width, and a height. For example, in the 2D coordinate system, we only have this direction, two directions, right? One direction and two directions. And if you are talking about 3D coordinate system, usually you will have one direction, two direction, three directions. Okay, be careful with the difference. We'll talk about the 3D shapes later in this course, okay? All right, so let's do some quick quiz here to check your understanding of what we just talked about. Okay, a person named Alice is thinking of a line. How many points on that line does she need to show another person named Bob in order for Bob to know exactly which line she is thinking about? Okay, I'll give you 1 minute to think about it, and then we'll talk about the solution together. It's okay, you can just keep your answers to yourself, because we're going to have a look at the solution together. So the answer here is 2, right? Have we got this correctly? The answer is 2. Because if Alice just gives up 1 point, he can't tell which line Alice is thinking about, because there are infinitely many lines that could go through that point. And we know 2 points can fix a line, right? Okay, consider another quiz. If M is the midpoint of section AB and N is the midpoint of BM, and if BN is 4, what is AB? So usually when you solve a geometry questions, it's better to sketch the question on a sketch paper, right? So here you should draw a diagram to illustrate the situation here. So basically we have a section A, B, M is the midpoint here, N is the midpoint of BM, so N is here, right? And it tells you BN is 4, so we know this length is 4, and that's the length of AB. So if this length is 4, N is midpoint, then this length is also 4, right? Then MB is 8, and M is the midpoint of AB, then we know this length is also 8, right? Therefore, the length of AB should equal 16, right? Okay, very straightforward question. And you have any questions? No? Okay, any questions, just interrupt me, okay? Otherwise, we'll have a look at the next concept, circles. Okay, so concept of circles. The set of all points that are the same distance from a given point is a circle. So basically, a circle is a set of all points that are equal distance to a center point. The given point is the center of the circle, and fixed distance is called the radius. We often refer to the circle by its center using this symbol here. So circle O, use this symbol here, refers to a circle centered at point O. And next, let's talk about the relationship between a circle and a line. A line that touches a circle at a single point is called tangent to that circle, while a line that hits a circle at 2 points is called a secant line. A segment connecting 2 points on a circle is a chord, and a chord that passes through the center of the circle is called the diameter. The portion of a circle that connects 2 points on the circle is called an arc. Okay? There are many trivial concepts. Be careful with this concept here, which we denote with endpoints of the arc MN if it's a shorter arc that connects M and N. The set of all points that satisfy specific conditions is called locus, and a circle is a special case of a locus. Okay, we'll use the diagram on the right to illustrate this concept here. So suppose we have a circle here, circle O, and some lines K, L, and M, N. Mn is actually a segment. And according to the definition we have just talked about, we know segment OA is a radius of the circle O, right? And segment MN, which is here, MN is called a chord in that circle. And line MN, if you consider MN is a line, then line MN is a secant line because there are 2 points of intersections with the circle, right? And line L, because line L only has 1 point of intersection with the circle at P. So here, line L is called the tangent line of that circle. And arc MN is a shorter arc, which is here. Okay, so if you want to denote the shorter arc, you can use arc mn. No, P and M is a longer arc here. Okay, let's do a quick exercise. In the future at right, identify whether each of the following is a secant line, a chord, a radius, or a diameter, or a tangent line of circle O. Okay, I'll give you 1 minute to think about this question. 怎么着？
先收一个1200的，因为那个还有一个70块钱不着急，但是那个1200的先把它收了。QW12。
QW OK。是谁呀？郭还是谁？
就写的是周可
周可涵。
国宏宇的是另外一个，国宏宇是123，国宏宇该算也收了就对了。
等会儿，你发给我吧，密码。
这什么意思？
一会儿我收啊。
你先搜那个好吧。
QWER 是吧？收了。
国宏宇呢？
国宏宇还没收呢。
收吗？
等会儿吧，你密码发我微信上就行。Alright, have you finished? So here, CO is radius of that arc, right? And how about line EF? Line EF only touches the circle at only one point, according to the diagram here. So it's a tangent line, right? And segment CD is a chord of the circle. Segment AB is also a chord, but as it crosses the center point, it's also called a diameter. The diameter is a special chord that cross the center point. Okay, CD, line CD touches line at 2 points, so it's a secant line. Any questions? Alright, then if no questions, let's have a look at another quiz. How do you denote the shorter arc with endpoints A and D, given the diagram on the top right? And how to denote the longer arc? Okay, this is very straightforward, right? So I'll give you the answer directly. So we can use the letter, use this notation A, D, with a small arc on top of it to denote the shorter arc, and use letter A, B, D to denote the longer arc, right? Any questions? No? Okay, then consider another quick quiz. Suppose point P is outside a given circle. Is it always possible to draw a line through P that's tangent to the circle. Okay. At current stage, you don't need to prove it. We'll have the tool to prove your answer later in this course. Okay, suppose we have a circle and a point P is outside a given circle. It looks like it's always possible to draw a line through P that is tangent to that circle, right? Or at least, actually, you can draw two such lines. So we'll prove this theory later in this course. Okay, next. What is the maximum number of possible points of intersection of a circle and a triangle? Can you make a reasonable guess? So the answer is 6. That's right, because a line segment can intersect a circle in at most 2 points, right? So suppose this is a circle. One side of the triangle can intersect with the circle at 2 points. The second side can also intersect with 2 points. The third side can also intersect it with 2 points. So the maximum number of intersections between a triangle and a circle is 6. That's correct. Alright, so let's have a look at a concept called Compass-and-Straightedge construction problem. This is a special problem in geometry. Straight edge and compass construction is the construction of lengths, angles, and other geometric figures using only an idealized ruler and a pair of compasses. The idealized ruler, such as a straight edge, is assumed to be infinite in length, have only one edge and no marking on it. Okay, so basically you cannot use it to mark things or measure things, measure lengths. The compass can be proved to transfer distances. So when performing constructions with a straight edge and compass, you can only draw line segment and circular arcs. You cannot use a ruler to measure segments. The operations you can perform are limited by the following. First, given a point, you can draw any lines through the point. Second, given 2 points, you can draw the line that passes through them both. Given a point, you can draw any circle centered at that point. Given a point and a segment, you can draw the circle with the center at that point and with radius equal in length to the length of the segment. And last, given 2 points, you can draw the circle through one point such that the other point is the center of the circle. These are the limitations of the compass-straightedge construction. But even with these constraints, we can use a compass and straight edge to construct many different type of geometric shapes. So let's have a look at an example to illustrate this concept. Okay, so for example, use your compass to find a point y on line k such that AB equals xy. So how we can do this? You have a compass at hand, or any straight edge, for example a pen or a ruler, but does not use as a measuring function. You cannot simply use a ruler to measure AB. Okay, I'll give you 1 minute to think about it. Okay, and I'll show you how we can do this on a computer screen. Okay, have you finished? So although you cannot use your ruler to measure the length of AB, you can use a compass to mark the length of AB, right? So suppose we have, sorry. Segment. All right, suppose we have a segment AB and we have a line C. We want to find a point E such that CE equals the length of AB, right? So you need to use your compass to mark the length of AB and then draw a circle here, such that the radius of that circle equals the length of AB, right? Then you will have 2 points of intersections. One of them is here. The other one is here. So either E or point H you can use such that HC or CE equals the length of AB, right? Can you follow me? Okay. Alright, next there are some trivial concepts about axioms, theorems, and conjectures. And here, be careful with the difference. Axiom, or sometimes called postulate, is a statement that is taken to be true without proof, to serve as a premise or starting point for further reasoning and arguments. Axioms can be combined to prove more complicated mathematical statements. We call such proven mathematical statements theorems. And a mathematical statement that is not an axiom but hasn't been proved false or true is called a conjecture. So let's have a look at some examples. So examples of axioms are as follows. These are the very basic statements made by a scientist Euclid, which are the starting point for us to prove any further theorems in geometry. For example, any 2 points can be connected by a straight line segment. Second, any line segment can be extended forever in both directions, forming a line. And given any line segment, you can draw a circle with a segment as a radius and one of the segment endpoints as center. And of course, all right angles are congruent. We'll talk about the right angles and what we mean by congruent shortly later in this course. And given any straight line and a point not on that line, there is exactly one straight line that passes through the point and never meets the first line. So these are called axioms. We don't need to prove them. They are true by default. You can treat them as starting point for any further proof of any other theorems. And next, let's have a look at an example of theorem. For example, the Pythagorean theorem is a typical example of theorem, which states that in any right triangle, sum of the squares of the legs equals the square of the hypotenuse. Do you know how to prove the Pythagorean theorem? Don't worry, you don't have to prove it now. We'll have the chance to prove this later in this course. Okay, here is just examples to differentiate a theorem and axiom. You don't have to prove axiom, but for a statement to be a theorem, you must prove it. Okay, the only thing we can use here is any axioms or theorems that has been proved. And example of conjecture. For example, if a person is making figures for an art object, he drew polygons and some of their diagonals. From these examples, the person Arthur makes this conjecture. If a convex polygon has n sides, then there are n minus 2 triangles formed when the diagonals are drawn from any vertex of the polygon. So is this statement true or false? At this point, we have not proved it right or wrong, right? And therefore this statement is called a conjecture. So here, this example is only to illustrate the difference between axioms, theorems, and conjectures. Make sure you use the correct terms when you describe a statement, okay? Alright, so basically that's the end of the first lesson. It's very basic, very straightforward, and nothing complex.